Okay, so this is the review from Friday and a little challenge. On Friday we talked about the slope of the line is just the ratio of rise to run. We describe it as the steepness of a line. We look at the change in y over the change in x, and I don't know if you remember I told you this little triangle means change. So you have change in y over change in x, which is equal to the y coordinates subtracted one from another over the x coordinates subtracted one from another. And notice I've got this pair, y2 is over x2, y1 is over x1. So I have to keep the ordered pairs in the same place when I subtract them. So number 1 says, determine the slope of the line that passes through these points. If you haven't already tried these, pause the video and go ahead and try to do these two problems before watching the rest of this. Okay, so I'm going to determine the slope of the line. So I'm going to do change in y over change in x. y2 minus y1. 9 minus 1. Since I put this y first on top, I have to put its corresponding x first on the bottom. So I have 8 minus 2 on bottom. 9 minus 1 we know is 8. 8 minus 2 we know is 4. And 8 over 4 reduces to 2. So the slope of my line is 2. So m equals 2, or 2 over 1. Same thing. So to extend your thinking a little bit, it gives you the value r and tells you that the slope is negative 2 over 7. So what I have to do is plug it in and solve for r. And there are multiple ways to go about doing this problem. So 4 minus r, y2 minus y1, over x2 minus x1. So notice, once again, since I put the 4 first on top, I'm putting the 3 first on bottom because it's its corresponding x coordinate. So 3 minus 10, and we know that once I subtract this out, I get negative 2 sevenths. So I'm going to go ahead and do what I know to do. 4 minus r over 3 minus 10. 3 minus 10 is negative 7. So take care of what I can. Equals 2 over, and I'm going to put this negative down here with the 7 since I had a negative 7 on the bottom. So now notice, these two things match. Negative 7 is equal to negative 7. So on top, I need 4 minus r to equal 2. So 4 minus r equals 2. To get r by itself, I would subtract 4 from both sides. So negative r equals a negative 2. Then I want to get r totally by itself without that negative there, so I divide both sides by a negative 1. What am I doing? 2 minus 4 is not negative 2. 2 minus 4 is negative. 2 minus 4 is a negative 2 divided by negative 1 gives me a positive 2. There we go. So my r, my value for r is 2. And we're going to look at another problem that doesn't work out quite as nicely as this one did, where the bottom values are the same. So once again, go ahead and pause the video and try this problem on your own. And then after you've given it a shot, click back on here to check your answer. And we'll set it up. 4 minus r over 10 minus a negative 2, we know is equal to negative 1/2. So I've got 4 minus r over 10 minus a negative becomes a positive. So 10 plus 2 is 12 is equal to negative 1/2. So see how I said it didn't come out quite as nicely here. We've got a 12 on the bottom and a 2 on the bottom. And the reason this is, you guys are familiar with the fact that 1/2 is equal to 2/4, which is equal to 3/6. Which is equal to 6/12. I could just keep on going. I've skipped 4/8, 5/10. We can go on and on and on forever. All of these fractions are equivalent. So I can have two different denominators and it be equivalent, but that doesn't really allow me then to set, I can't set 4 minus r equal to negative 1 because the bottoms aren't equal. So at this point, what I would recommend doing is doing cross products. We've got this equal sign here in the middle, so I know that I can cross multiply. That times that, and that times that. So 12 times a negative 1 is negative 12. And I'm going to set that equal to 2 times the entire quantity, 4 minus r. So at this point, I'm trying ultimately to get r by itself. So I'm going to get rid of this 2 here. Divide both sides by 2. Negative 12 divided by 2 is negative 6. And that is equal to 4 minus r. So I'm going to get rid of this 4 by subtracting 4 from both sides. So I've got negative 10 equals negative r. I need to get rid of the negative, divide both sides by negative 1, and r equals 10. So if I plug that back in, 4 minus 10 is, 4 minus 10 would be negative 6. So I end up with negative 6 over 12, which is in fact equal to negative 1/2. So here's another one for you to try if you'd like. Negative 1/3, or negative 1 comma negative 3, and 7 comma r is equal to 3/4. I'm going to go ahead and skip it, let you try it on your own, and I am going to move on to the direct variation lesson. So the standard that I want to cover in today's lesson is standard A.CED.2, and the objective is that you will be able to write and graph a direct variation. And I want you to be able to look at a table, look at a graph, look at an equation, and determine if it's a direct variation or not. And if it is, to write the direct variation. So in order to be able to do this, you have to know what a direct variation is. Well, a direct variation is an equation in the form of y equals k times x, and we say that k is the constant of variation. And we can also say that y varies directly with x. So when I say that y varies directly with x, that means there is a relationship there. And that relationship is formed by the fact that this k is a constant. A constant means that it's never, ever going to change. So in order to find the constant of variation, we've got to find the slope of the line. So the way that I find slope is by looking at the 2 points. My slope is my rise over my run. We said that we have to rise out of bed before we can run. So I look at the rise on the top over the run to find the slope. It went up from here to here, 1, 2, 3 units. And then it went over 1. So my slope, or my constant of variation in this case, is 3. So k equals 3. So now to write the direct variation, I've got to plug that k in. So my direct variation is y equals 3x. The constant is 3. The direct variation is the whole equation, y equals 3x. So let's try another one. I want you first to find the slope of the line. Rise before we run. Okay, I've got to rise before I can run, but if I start at the leftmost point, I'm not really going to be rising. If the elevator's at the top, there's no place to go but down. So I fall down 2 units and I move over 1. So since I went down 2 units, I put negative 2. So my slope then is negative 2 over 1. So the constant of variation then, that would be k, is equal to what the slope is, which is negative 2. So write the direct variation. I just plug into k. Y equals negative 2 times x. Okay, so what I want you to do on this problem is determine, is this a direct variation? Well, we know to be able to determine whether or not it's a direct variation, I have to have it in the form of y equals kx. And obviously, this isn't. I want y by itself. Right now, y's got a 3 attached to it. It's got this positive 4x attached to it. And we want it to be totally by itself. So my first move is going to be to move the 4x over to the other side. So I'm going to have 3y equals, remember, if I'm moving it, I'm getting rid of it from this side. Therefore, I'm going to subtract. Since it's a positive, 4x, to get rid of it, I would subtract 4x. Whatever I do to one side, I must also do to the other. So when it comes over here, it's a negative 4x. And then I still have that positive 6 hanging out over here. At this point, I'm trying to get y by itself. I've got to get rid of the 3. So y times 3, to get rid of it, I'm going to divide by 3. If I do that over on the left, I must also do it on the right. So I have y equals negative 4/3 x plus 2. And I want to know, is that a direct variation? Is it in the form of y equals kx? And no, it is not, because if I was going to have something out here, it would be plus 0. There's nothing out there. So this has a plus 2. So I know that it is not a direct variation. If I were going to graph this, we always graph the y-intercept first. Come up here to the positive 2. Then my slope tells me to drop 4 units and run over 3 units. So then here would be my other one. This is what it would look like. It doesn't pass through the origin. If you look back at the previous problem that we did, this one passed through the origin, this one passed through the origin. A direct variation should always pass through the origin. Looks like I skipped one. So I want to determine, is this a direct variation? Same thing as what we did here. We want to get y by itself. So what I want to do is divide both sides by 7. 7 divided by 7 is 1. 1 times y is y. So now I have y by itself. And then I've got my slope over here, 2/7 x. So I want to graph it. The way I graph it is I always start with whatever number is out here. Plot that first on the y-axis. Well, since there's no number out there, I start at 0, because I could put a plus 0 there and it wouldn't change my equation. So from there, I rise 2 units and run 1, 2, 3, 4, 5, 6, 7. 2/7. My line isn't very steep, which stands to reason because my slope isn't a very high number. It's 2/7. Okay, so now for the equation part, I guess, of the lesson. It says if y varies directly with x, and y equals 28 when x equals 7, write a direct variation that relates x and y. So what I need to do is I always like to begin with the end in mind. Look at where I'm going. Y equals kx. I know that I want to find the value of k in order to have a direct variation. Y equals kx. So what I have to look at is what they gave me. They told me that when y is 28, x is 7, or when x is 7, y is 28. So I know I've got this ordered pair, 7, 28. And I can plug that in for x, plug this in for y, and that's going to give me enough information then to solve for k. So I've got 28 is equal to k times 7. So I know to get k by itself, I'm going to divide both sides by 7. 28 divided by 7 is 4. So 4 equals k. And after doing a few of these problems, you're going to realize the pattern over and over and over again is to get k by itself. I have y equals kx, divide both sides by x, and that's going to give me k. So k is 9 times out of 10 equal to y over x. If we're dealing with fractions, then we're going to want to multiply by the reciprocal instead, which we'll get to some examples like that. But if I'm just dealing with whole numbers, this is what I can use to solve for k. So now it tells me, now that I know that k is 4, I got to plug it back in, write my direct variation. So y equals 4x. That is my answer to the first part, because it said to write a direct variation. I did, y equals 4x. Then it says, part 2, find x when y is 52. So using y equals 4x, I want to know what is x if y is 52. So I plug in 52. I want to solve for x. So I want to divide both sides by 4. I'm thinking of a standard deck of cards here. There's 4 suits. 52 divided by 4 is 13. Can you tell I've been teaching a probability lesson? So x is equal to 13 in part 2. Okay, so at this point I would go ahead and pause the video and I would try this one on my own if it were me. And then you can click back on and check your work. It says if y varies directly with x and y equals 12 and x is 4, so when x is 4, y is 12, I've got this ordered pair. Find y when x is 7. I've got 7 and I don't know the y. That's what I'm trying to find. But in order to do that, I'm going to have to use this information first to find k. I've got to know what is my constant of variation. So we just said in the last problem, the way that we can find k is by doing y divided by x. That works if it's whole numbers. So using this ordered pair, k is equal to 12 over 4. So my k is equal to 3. Okay, now I am done with this. This is now useless information. I only needed that ordered pair to find my k. It's dull and null and void. It's gone. I don't care about it. Throw it out the window, whatever. It's dead to me. I just needed it to get this piece of information. Now that I have this piece of information, I can write my equation, y equals 3x. And then I can plug this value of x in and solve for this value of y. So 3 times 7 is 21. So the answer to the question, find y when x is 7, is 21. Okay, here's another one. I'm gonna leave it up here for a second so you can write it down and try this problem on your own. But I want to move on to a little bit more complicated one. One that involves fractions. So we said so far that we could do k equals y divided by x. And that's true. We could plug it in for this, but we've got fractions. And that's going to get pretty ugly if I say k equals 2/5 divided by 1/3. That's nasty. How can I do that? Can't do that without a calculator. You could type it in the calculator. And if you type it in correctly, you'll get the correct answer. But I don't like using a calculator. I want to do it myself. So I know if I'm dividing by a fraction, what I can do is multiply by its reciprocal. So I'm just going to rewrite it. Y equals k times x. My y is 2/5. We don't know k. We've got to find it. And x is 1/3. So to get k by itself, I'm going to multiply by the reciprocal of 1/3. That's going to become 1 over 1, which is just 1, which leaves me with k. Well, I know if I multiply this side by 3 over 1, I must also multiply this side by 3 over 1. 3 times 2 is 6. 5 times 1 is 5. So my k equals 6/5. But what I'm ultimately looking for is what is y if x is 1/4. So I can write my equation. Y equals 6/5 times x, but my x here is 1/4. So I can go ahead and simplify. I see that both of these are divisible by 2, so I'm going to go ahead and do that. 6 divided by 2 is 3. 4 divided by 2 is 2. Now I can multiply. 3 times 1 is 3, and 5 times 2 is 10, and there is my answer. So when it's dealing with fractions, you really don't want to do the y divided by x. Instead, you want to work it out algebraically and multiply by the reciprocal. Here's another one. Go ahead and pause the video and try it, then click back on and check your work. Okay, so here is the answer. I went ahead and solved by multiplying both sides by the reciprocal, and I got 2x. Since I'm dealing with fractions, I'm going to keep that 2 as 2 over 1. Then I plugged it in. 2 over 1x equals 3/16. Since I'm dealing with fractions, instead of dividing both sides by 2, I multiply both sides by 1/2 and got 3 over 32 as the answer. Okay. It says for the data in the table, I want to know, does y vary directly with x? And if it does, write an equation for the direct variation. So far, we have been looking at the k, the value of k. And in direct variation, it has to remain constant. So what I'm asking is, would the value of k for this ordered pair and the value of k for this ordered pair and the value of k for this ordered pair remain constant? Would it be the same for each one? So remember, we said we find k by doing y divided by x. So what I'm asking is 6 divided by 4, the same as 12 divided by 8. And is that the same as 15 divided by 10? And it is. And the way that I can figure this out is by reducing all of these to the simplest form. And each one of them reduces to 3 over 2, or 1.5. So then it says to write the equation for the direct variation. So I want to know, what is my constant? What is k? It is 3 over 2, or 1.5. So 3 over 2 x equals y is my direct variation. Okay, let's try this one. For the data in the table, does y vary directly with x? So once again, I'm going to set it up the same way. Is 3.2 divided by -2 the same as 2.1 divided by 4? And I'm going to stop right there. I don't need to go any further because a positive divided by a negative is a negative. A positive divided by a positive is a positive. Clearly, a negative and a positive are not the same. So I cannot write a direct variation for this problem. This was a really lengthy video, but I hope that you take the time to at least watch the parts that you're struggling with and make sure that you're learning this, because what we're learning in this lesson and this whole unit dealing with slope is very, very important for you to know moving into geometry and then algebra 2 and just all of your future math classes from here on out. This is a very, very important concept, and I hope that you take the time to really learn it. Have a good day.